नमस्कार, म रुद्र काफले उस्टर म्यासाचुसेट्सबाट Physics is fun. This is episode 4. I hope you are enjoying and learning physics with me. So in today's session, we will learn more physics. So let me quickly check the volume of my phone. Okay, I'm setting to maximum. I hope you can hear me. Okay, so in the last 3 episodes, since first episode, we are talking about forces and Newton's laws of motion. Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, right? We talked about that. In the last class, we talked about some different new concepts like friction and center of gravity. So I also asked several questions in the previous episodes, right? So a couple of questions that were asked from the viewers were what is the difference between center of mass and center of gravity, and there were some other questions too. Let me try to answer those questions qualitatively. Okay, because of my video settings, I am doing most of the things here qualitatively. Okay, my goal is to develop building concepts in the young children or students. Okay, so if you are accompanied with your parents or teachers and watching this video, watching this Facebook Live, right? So please get help from them in getting the answers quantitatively. Okay, so I left 3 questions in the last class. What were the 3 questions? What is the center of mass, or where is the center of mass of the Earth and Moon located? Where is the center of mass of the Sun and the Earth located? Where is the center of mass of 2 binary stars located? So those 3 questions, if you did calculations, that's fantastic. If you have not done, please don't worry. Let me explain qualitatively how to get the answers, or the concepts on those 3 questions. The first question was, where is the center of mass located if we are considering the Earth and the Moon? So since I'm not telling you the formula here, you can ask your parents or teachers or seniors who are around you. So there is a formula to calculate the center of mass. So if you apply this formula, the masses correctly and the distances, so you can calculate the position of the center of mass. Since the Earth is much more massive than the Moon, so the center of mass between the Earth and the Moon is very close to the Earth, maybe towards the center of the Earth. The same way, the center of mass, if you consider the system of the Sun and the Earth, the center of mass is very close to the center of the Sun, because the Sun is much more massive than the Earth, right? So, but if you consider 2 objects of similar masses like binary stars, the center of mass is in between, at the center, at the center of line joining the 2 stars, right? So you can calculate and then find the position of the center of mass by using the formula. Okay, there is a formula. For example, if you consider x1, x2, m1, m2 for the 2 masses and x1, x2 to 2 coordinates, then you can calculate the center of mass by m1 times x1 plus m2 times x2 and divide the whole thing by m1 plus m2. You can find this formula in the book. Again, let me repeat. The goal of this program, this Physics is Fun, is I would like you guys have more fun and learn the concept. And of course, to understand completely, you need to apply these formulas and you need to do calculations. You need to do problem solving. So until and unless you solve the problems, you will not understand physics completely. Okay. So let me focus the concept today. One more, there was a question: what is the difference between center of mass and center of gravity? Let me answer that question. If the object is small, right, in the gravitational field of Earth, for example, right, is center of mass and center of gravity coincide. But if the object is very, very long, so that gravity, the effect of gravity at one end and the effect of gravity at other end and in different points is different, then center of mass and center of gravity do not exactly coincide. So that is the difference. So what is the center of mass? Center of mass of an object is the point where all mass is assumed to be concentrated. Center of gravity is the point, right, where the weight of the object acts, right? So for example, let's consider this object. Let's consider this object, right? This is a badminton cork, right? So see, the mass is heavier here, right? And in the feather side, there is less mass, right? So if you let the object, like say, let me make it upside down like this and let it go. Please watch what happens. Please watch what happens. It turns around, but because of the length of my height, so the distance probably you may not see, but you can try, right? So the center of mass and center of gravity more or less coincide. In this case, the object is small, okay? So if you consider a uniform ruler, which I showed you in the last class, the center of mass and center of gravity is at the center, right? Both coincide, okay? So and there was another question. So I asked you, and then actually some of you answered that question correctly. So if we have two objects, right? If we have two objects like this, two surfaces, right? And then you move one object on top of other, there is a force of friction. So I asked you a question. Suppose we have a metal block. Suppose we have a metal block, two metal blocks, like made of steel or made of copper, right? And if you move the two objects relative to each other, right? So there will be friction. And I asked you a question. Now what you do is, please increase the smoothness. Make the surfaces in contact smoother and smoother and smoother. Then what will happen? So in that case, what will happen? In that case, the contact surface, like the contactness, will go up. And as I explained in the last class, friction is because of the result of electromagnetic force. It is because of the interaction between the charged particles between the two surfaces, right? So because of that, when you make the surfaces smoother, and smoother, what will happen, right? Those two, the particles from the two surfaces, the molecules or atoms from the two surfaces come closer and closer and closer. So because of that, what will happen? The friction will be higher and higher and higher. So a very interesting situation may arise. I believe some experiments have been done in space. So if the two surfaces are very, very smooth, and if you are doing the experiment like you want to move one surface onto other, you can hardly move. The friction is so large. Actually, the two surfaces do not identify each other. They don't feel the difference. They look to be identical, right? So if the surfaces become smoother and smoother and smoother, what will happen? The friction will be larger and larger and larger. So here is a contradiction. It seems to be a contradiction, right? So if the surfaces become smoother and smoother, friction rises. Then what do we use? Oil or grease, right? Or so to make to reduce the friction. The story is different. Okay. So when we use oil in moving parts, what happens? There is a small layer of oil. Okay. So there is a small layer of oil between the two surfaces, and because of that, the two surfaces do not exactly come on top of each other. And because of that, the surfaces are lubricated. So the friction is, there will be less friction. But it is not because the surfaces are smooth. So the oil or grease which we have introduced between the two moving surfaces, like in a bicycle chain or moving parts of machine, so what will happen? Because of that third layer of oil or grease, right, that does not allow the two surfaces in exact contact. There is a small layer there. So because of that, there will be less friction. Exactly the same kind of thing happens when we drive in ice, or when we, or better say, when we drive, there is, let's say, a thin layer of water on the road. What happens? The tire of a car or a vehicle doesn't exactly come in contact with what? Contact with the road. So there is a thin layer of water. So that might reduce friction. Okay? So oiling or using grease between the movable parts is not because that the surfaces are made smooth. It is because we are introducing a new material there. Right? So because of which the two surfaces do not come in contact directly. So that is why that will reduce the friction. Okay? I hope I answered your questions. So if you guys have this kind of questions, please write in comment. Right? I will try my best to answer your questions. Okay? So you will learn only asking questions. You will learn only by practice. You will learn only by curiosity. Albert Einstein said, never stop questioning. So please ask questions. Write questions in the comment. So if I don't have time in the regular week, so I will definitely try to answer those kind of questions in the next episode, next Saturday. Okay. So today we will be learning some more application of Newton's laws of motion and some more concepts in physics. Right. One concept I would like to introduce today. Right. So in every class I am introducing one new concept. Okay. Or maybe multiple, but at least one new. So for example, in the last class, I talked about center of mass and center of gravity. Probably I also introduced friction in the last class, in the last episode. If you missed previous episodes, episode 1, physics is fun, episode 1, physics is fun, episode 2, physics is fun, episode 3, I have uploaded them in YouTube. Okay, so please, you can watch in there. Right? So now, today I am introducing a new concept, the concept of momentum. Okay, the concept of momentum. M-O-M-E-N-T-U-M. Momentum. So I am introducing a new concept of momentum. Okay, so what is momentum? So an object has a mass, right? For example, if I consider this cell phone, right? If I consider this cell phone, it has certain mass. If you consider an apple, it has certain mass. Do you remember? I told you an average sized apple has a mass of about 100 grams, which is 0.1 kilograms. Right? So the same way, this object has about that mass, or slightly more. Right? So if this object is at rest, this object is at rest, no matter what, it has mass. Right? Because mass is the quantity of matter in the object. So this object is made of, this cell phone is made of material. So it has mass. Right? It has mass. But if the object is at rest, the quantity which I am trying to introduce, what I am calling is momentum, is zero. So it has mass, but its momentum is zero. What does that mean? So you will define momentum as the product of mass and its velocity. When an object is moving, it has momentum. When an object is not moving, its momentum is zero. So the product of mass and velocity is momentum. A moving object has mass as well as velocity, right? No matter whether the object is moving or at rest, it has mass. But a moving object has mass and its velocity. So if you take the product of mass and velocity, if you multiply, right, so it has momentum, right? For example, let's consider an apple, right? So when I have an apple, right, so it has mass of how much? 100 grams. Please convert into what we call SI unit in kilograms, so 0.1 kilogram. Suppose it is falling at a velocity of 10 meter per second, velocity of 10 meter per second, so mass times velocity 10 times 0.1 is 1 kilogram meter per second. That can be changed to Newton second. Okay, that is the unit of momentum. Okay, I'll give you some examples, practical examples of momentum in a few minutes. But let me introduce first, let me explain more. So an object when it is moving, an object when it is moving, right, it has momentum. And by the way, I haven't explained in detail about vector and scalar quantity. I gently introduced in one of the previous episodes. But here, let me emphasize one more thing on momentum. Momentum is a vector quantity. It is a vector. Momentum must have magnitude. Momentum must have direction for complete specification. If you write momentum of an object is 10 Newton, for example, 1 Newton second, it is incomplete answer. That's wrong. Your teacher will not give you full credit. Your teacher will not give full mark. If you calculate momentum, that is mass times velocity, then you must specify its direction. Okay? Please, let me repeat. Momentum is a vector quantity. It has magnitude, some value, and direction. And the direction of momentum is the direction of velocity. For example, suppose if you are watching, if you are in Kathmandu now and watching me, let's consider like somewhere in, let's say, Baneswar, okay, New Baneswar. Let's consider New Baneswar Chowk, okay. So if a car is moving towards, let's say, Babar Mall, right? So you can multiply the mass of the car with its velocity, right? That is the magnitude of momentum, mass times velocity, in Newton times second, Newton second. What is the direction? So direction is towards Babar Mall, in that direction, in the direction of the velocity. Okay? So that is momentum. So what is the importance of momentum? Why do we need to understand this? Because, as I mentioned in the very first class, Newton gave 3 laws of motion. Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Originally, Newton did not write his second law of motion like F equal to ma. F is the force, m is the mass, a is acceleration. Okay, force, mass, acceleration. If the viewers in now watching, if you are in a junior class, right? So please don't worry too much. I'll explain these concepts again in future episodes, right? So force is equal to mass times acceleration. What is force? A vector quantity. What is mass? A scalar quantity. What is acceleration? A vector quantity. So force is equal to mass times acceleration, right? So Newton did not write that way. Newton wrote Newton's second law of motion originally in terms of momentum. Okay? At some point I will introduce the original statement of Newton's second law of motion. We need to understand that to understand several other kind of phenomena. For example, one immediate thing is the launching of rocket. Today, NASA is launching SpaceX. Today, NASA is maybe later today is Saturday, it has been scheduled. If the weather is good, NASA will be launching SpaceX, a rocket to space, right? So if we want to understand the physics behind it, so F equal to ma doesn't work. What do we need to learn? We need to learn Newton's second law in a different form, in the original form given by Newton. So what was that? Let me just make the statement now. I'll explain in future classes. Okay? Future episodes. What is that? The rate of change of momentum is directly proportional to force, and it takes place in the direction of force. That was original form of Newton's second law of motion. Please don't worry too much at this point. Today's class, I am focusing on one new concept, that is momentum. So what is momentum? It is the product of mass and velocity. What is qualitatively? What is it qualitatively? It is actually quantity of motion. How much motion does an object possess? How much motion does an object have? Let's consider an example I gave you in the previous episodes. Consider a bicycle, consider a motorcycle, consider a car, consider a truck. Okay, suppose all of them are moving with the same speed. Let's consider for now quantity, just the magnitude of velocity, or we can say velocity. Let's consider, suppose all of them are moving in the same direction. All of them are moving in the same direction in a highway. All of moving are in the same direction in a highway. A bicycle, a car, a motorcycle, and a truck. So suppose they are moving with the same velocity. Okay, suppose they are moving with the same velocity. Okay, now we would like to know which has the largest amount of quantity, largest amount of motion. What I'm asking is, which of these objects, which of these vehicles, a bicycle, a motorcycle, a car, a truck, has maximum momentum? All are moving with the same velocity. Let's say a bicycle is moving, let's say 10 miles per hour. 10 miles per hour. In the United States we use mile per hour. In Nepal, in Europe, in Canada, in other countries we use kilometer per hour. So let me consider a mile per hour. Please try to convert these kind of units, by the way, into meter per second. Please try. Please practice. They are useful skills in life. Okay. So suppose a bicycle is moving with a velocity of 10 mile per hour towards, let's say, towards east. 10 mile per hour towards east. A motorcycle 10 mile per hour towards east. A car 10 miles per hour towards east. A truck 10 miles per hour towards east. Right? So if all of them start from rest, they will cover the same distance. Right? But those objects have different momentum. Why? Momentum is the product of mass and velocity. So of course, bicycle has the least mass. A cycle has the least mass. So mass times velocity, it will be less. So bicycle has less momentum. Okay, make sense? Bicycle has least momentum. It is least of all. Motorcycle has bigger mass. It is heavier, right? So it will have more momentum. Motorcycle has mass, more mass times velocity. Although the velocity is same, right? Its momentum is higher, because the product of mass and velocity is more. Make sense? Consider car. Car has even higher mass. Although the velocities are same, the product is more, because mass is higher. Right? So the momentum is even higher. Right? So consider now truck. It will have the highest momentum. So mass times velocity, because higher mass, so it has more momentum. Suppose, now here is a question. So I am leaving this question with you. Okay? So if in the audience, if you are parents, if you are teachers, okay, if you are senior students, please think about this and help your siblings, your sisters or brothers who are in lower classes. So the question is this. So a bicycle, okay, a bicycle, a motorcycle, a car, a truck, okay, those four objects, they are moving with the same velocity, in the same direction, right? They have, of course, they have different masses. Now, if we would like to stop at the same distance, let's say they start from some point, and then we would like to stop, like let's say after 1 meter, after 10 meters, let's say. So since the truck has a bigger length, 1 meter doesn't make much sense. Let's consider a bigger distance, let's say 100 meters. So we would like to stop all of these vehicles at 100 meters. In which case we need to apply larger force. Why? In which case? For a bicycle, for a motorcycle, for a bicycle, for a motorcycle, for a car, for a truck. In which case we need to apply more force. Please think about this question. Okay? So we'll discuss the answer to this question in the next class. Okay? So please let me summarize what I talked until this point of time. I introduced a new concept in physics. If you already learned, if you already know, fantastic, good job. Okay, if you did not know it before, so I introduced today momentum. Right? What is momentum? Momentum is the product of mass and velocity. How do you calculate momentum? How do you calculate momentum? Find the mass and multiply it by its velocity, then you will get momentum. Larger the momentum, so larger the mass, although the velocity is same, larger the mass, larger will be the momentum. Okay? So, and also I told you that momentum is a vector quantity. Again, in physics, when you learn physics, please always keep in mind, is this quantity a vector? Is this quantity a scalar? That is a very important concept. When you start solving problem, if you do not know whether the quantity is a vector or a scalar, so you may not get the right answer. Okay? So I introduce a new concept, momentum, the product of mass and velocity. And by the way, usually it is denoted by a letter P, a lowercase p. So if you have a paper, if you have a pen with you and a paper and a notebook, please write P, okay, P, and then write arrow on top of P is equal to m mass times velocity v. Velocity v, like P for pen, M for man, V for van. So P is equal to mv. Right? P is, please give arrow on top of P. Please give arrow on top of V. Please don't give arrow on top of M. That will be wrong. Why? Because mass is a scalar quantity. You don't need to associate it, you don't need to assign any direction for mass. Mass is a scalar quantity. For example, if you have a pack of, if you have a bag of 10 pounds potatoes, you don't need to tell anybody that I have 10 pounds potatoes in this direction or that direction. You don't need to tell that. Okay? So mass is a scalar quantity. Please don't give arrow on top of mass. Please give arrow on top of momentum. Please give an arrow on top of velocity. So any quantity in physics, if it is not the ratio of like quantities, must be associated with units. You must write unit. If you forget unit, that doesn't make sense. Units are actually really important. Around 1999, I believe, because of the discrepancy of unit, NASA had to lose millions of dollars because of the discrepancy of American system, SI unit, International System of Units, and British System of Units. So we need to be very careful. We need to be very careful in writing units. If you don't write units correctly, even if you calculate the magnitude, the answer correctly, that doesn't make any sense. For example, if you say, I have an apple with 0.1, what is that? 0.1 meters, 0.1 kilogram, 0.1 grams, 0.1 seconds. So you need to specify the units. Students from very lower class, whenever you think of some physical quantity, ask a question to yourself, to your teachers, to your seniors. What is the unit of this quantity? Mass, what is the unit of this quantity? Kilogram, gram, pounds, in different systems, right? In mostly we use SI unit, that is kilogram. Velocity, what is the unit? Meter per second. Distance, what is the unit? Mile, meters, kilometers, like that, right? So I hope I introduced, and then also I forgot to tell you. I think I already told you, but let me remind you. The unit of momentum is mass times unit of product of unit of mass times the unit of velocity. What is the unit of mass? Kilogram. What is the unit of velocity? Meter per second. So you can simplify that as Newton times second. Please try. How can you write kilogram meter per second as Newton second? Please try. Okay? if you have any problem, ask help from your seniors, from your teachers, from your parents. Okay, so kilogram times meter divided by second is equivalent to Newton second. Okay, so this is a new concept. I introduced a new concept today, that is momentum. Okay, so let's do some fun activities. Okay, I always want to introduce some fun activities because the name of the class, the name of the session is Physics is Fun. Okay, I have a glass. Okay, empty glass. It has nothing in it. That means it has air, of course. I mean, not other like water or other liquids or other materials here. It has air, right? So it has nothing, right? So I put this glass on top of table. Okay, and I have a photographic paper. Actually, this is picture of my son printed several years ago, right? So if you guys have, if any of you have this kind of photograph or postcard, something like that, you can repeat the experiment. Again, when you do any experiment, please take help of seniors. Please do not hurt yourself when you do the experiments. Sometimes science experiments can be dangerous. We need to be very careful. And I have a coin here. So this is a coin. This is actually 1 Nepali rupee, right? So I had in my pocket, like I found in the piggy bank or whatever, right? So this is 1 Nepali rupee. You can use, if you are in the United States, you can do this experiment with quarter, right? In Nepal, you can do with any coin. Okay. So what I do is I am putting this photographic paper, or you can use postcard, on top of the glass. Okay, and putting this coin at the center, right, on top of the this photographic paper or postcard. Okay, so what I am going to do now is I am pulling this photographic paper away, right? Let me do it gently first. So see, the coin came with the postcard. The coin came with the photographic paper, right? This picture, okay? So now, what do I do? Instead of doing that, so what do I do is, I push the postcard with jerk, right? So I have placed the coin in the middle, right? So I pull this with a jerk, okay? So please watch what happens and try to think about why did that happen so, okay? So let me do that. 1, 2, 3, go. Oh, it failed. See, sometimes you need to know how things fail. So it failed. Don't worry, I'll try one more time. Probably I didn't do the best way, okay? So let me do one more time, okay? 1, 2, 3, go. So what happened? You saw? So I pulled this photographic paper suddenly, right? And the coin fell into the glass. Okay? By the way, when you do experiments, things can fail. You need to know. You need to think about why things failed. You may not get success on everything in the first trial. Okay? Let me remind some history. Michael Faraday, I will tell you in future episodes, Michael Faraday, one example immediately comes in my mind, failed several times. Thomas Alva Edison failed about like 1099 times while he was trying to invent electric bulb. So if anything fails, please think critically. Please don't be frustrated. Okay? So that was I failed for the first time. Probably I did not use a good amount of force, right? So let me try again whether it works. Okay, it should work. Okay, so let me do that. Okay, in the middle. 1, 2, 3, go. It worked. So what happened? When I pulled the photographic card, suddenly the coin fell into the glass. Why? What is the physics behind it? What is the physics behind it? Okay, we already learned, right? This is Newton's first law of motion. or you can call inertia of rest, right? Because Newton's first law of motion is actually inertia, combination of inertia of rest and inertia of motion. That is actually Galileo's law of inertia. Okay? What does it say? It tells that if an object is at rest, it tends to be in the state of rest. If it is moving, it keeps on moving. Until when? Unless you apply external force. So in the first case, what did I do? In the first case, I pulled it gently. So I applied force on this. So there is friction between this guy and this object. They came together, right? But now, when I pulled suddenly, right? What happened? When I pulled suddenly, I applied force on this. But I did not apply force on the coin. So, coin wanted to be at rest. That's the law of physics. Because I did not apply force on the coin, and because of gravity, it fell into the glass. Right? Because it was right on top of the center of glass. Right? So it simply fell down. Into the glass. Because of inertia of rest. This coin wanted to remain at rest. Because I didn't apply force on that. I applied force on the photographic plate. This photo. Right? You can use postcard if you have. Right? So this very simple experiment is very illuminating. It explains about the Newton's first law of motion. If an object is at rest, it tends to be in the state of rest. If it is in moving, if it is in the motional state, it tends to continue in the state of motion, unless there is an external force applied on it. Let's try to. So that is the proof of principle, or that is the concept. Let me apply this in some real situation in our daily life. Okay. So I have multiple books here. Okay. Let me make a stack of books. This book here. Book number 2. Okay. Book number 3. Okay. Actually, I want to put this book down there, and then another book right here, right? Another book right here, and then this, like this. Okay. So, like what do I want to do is, suppose if any of you want to do, what do you want to do is, let me try to put in view, right? So I have this book, this book, right? Let me do this book. Okay. So what I would like to do? Okay. What I would like to do is, I'm asking you a question. Okay. First, before I do, make a kind of think about that. So I would like to pull this book out without letting other book move or fall. So where is this kind of we are going to use some physics here, of course, right? So in practical life, where is it important? For example, if someone is working in press, in publication house, there are stacks of books, like hundreds and thousands of books. So a customer came and asked, can you please pull this book? I want this book, not other books. Right? There are two ways. You will dismantle all, remove all the books and take one out. But can you do something different? Because you can, because you learn physics now. You can, right? So what can we do? So see, now let me try. I'm slightly off the view. So I am trying, if I try to pull this book gently like this, all books come together. That's not my goal. What do I want to do? I want to pull this book, and then I don't want to let other books fall. Right? So what do? I apply exactly that idea. Let me try first, and hopefully I will not let my phone fall. Okay, so let me try. Okay, so I would like to do this. Okay, so I want to, when I do gently, all books move. But what I like to do is I pull it suddenly. Okay, so let me do that. 1, 2, 3, go. See, I pulled the book out. Do you see? I pulled the book out, right? Other books are not falling, right? So why? How did that work? How did that work? Can you please think for a minute? Why? I pulled only this book out, right? I pull only this book out. All other books are on top of each other. They did not fall. Why? Why is that? What is physics behind it? Exactly the demo which I did before with a coin and a photographic card. So what happened here? So I applied force only on this, only on this book. But I did not apply force on other books. So other books wanted to be at rest. They tend to be in the state of rest. Right? They tend to be in the state of rest because of inertia of rest. According to Newton's first law of motion, an object changes its state of rest or motion only when you apply force. Not by itself. It doesn't happen by itself. So I applied force on this book, right? I applied force on this book, and then that came off. Then that came out of the stack. Okay? Okay? Make sense? So this is how you need to apply, right? But again, when you apply physics, please be safe. Please don't hurt yourself. Okay? Sometimes experiments can cause risk. They may be unsafe. You need to be very careful. If you are children, and you cannot do, please don't try yourself. Please ask your parents or teachers so that they will help you. Okay? Good. So now I would like to do one very important experiment. Okay? Very important demo. Very interesting demo. Okay? If time permits. Okay, let's see. Now I have about 17 minutes for my hour. Okay, so hopefully I can do that. So what I'm going to do now is a very, very interesting demonstration. Okay? And probably I may not be able to introduce the concept here, so I might leave that with you, and then we'll talk about that in the next class. Okay? So I have tennis balls here. Ball number 1. Ball number 1. Ball number 2. Actually, it is labeled. They have labeled pen 3. So that is not. I didn't number that. So number 2, number 3. They are identical. They are identical balls. Identical balls. What is the meaning of identical? They have same mass, and their makeup is also the same. Okay. So I let the ball go. It falls. Why? Why is that? You already know. That's gravity. Okay? By the way, let me tell you one thing interesting. So if you are students of lower level, it might be difficult for you. Please don't worry. We'll talk about that in future. But if you are of higher level, probably you may follow what I am telling you. So gravity is the oldest known force. Gravity is the oldest known force. In the very first video, in the very first Facebook Live, in the first episode, I introduced forces in nature. All forces, whatever we see around, are classified into 4 groups. Gravitational force, number 1. Electromagnetic force, number 2. Weak nuclear force, number 3. Strong nuclear force, number 4. So those 4 forces, right? So the object falls down, that is gravity. So it is the oldest known force. People knew about this force much more than other forces before. Unfortunately, it is the least understood force. Believe me or not. What causes gravity? So, for example, if you ask your teachers, if you ask your seniors, if you ask me, what do I tell you? What do they tell you? What causes gravity? Mass. Yeah, right? Because that is Newton's law of gravitation. F equal to some constant called universal gravitational constant, product of two masses divided by the square of the distance. That is the force, right? What causes the gravitational force? Mass. That's what we say. But it is not only that. We need to go beyond. For now, you are good. For now, you are good. So just follow Newton's law of gravitation, right? If that was the ultimate answer, Einstein's general relativity would not have come, right? So gravity is the least understood force. Gravity is the oldest known force. Gravity causes an object fall. That's oldest known force, right? But there are a lot of things to be understood in gravity. Theoretically, how do we understand gravity? What causes gravity? Okay? Anyway, so this object I am holding, it is at rest. What is its velocity? 0. It is at rest. I let it go. It falls. This kind of motion is called free fall. This kind of motion is called free fall. F-R-E-E, free, F-A-L-L, fall. Please note down these two words. If you are students, please write down those. If you learn physics in future, if you study physics in higher classes, if you would like to make career in physics, you will be learning more and more on this about these terms. Free fall. Please write down free fall. Right? So this object is in free fall. Right? Make sense? Free fall. Okay? Let's say this is about the size of apple in terms of mass. So how much is the mass? Maybe about 100 grams. I have not measured exactly, maybe slightly less. It's slightly lighter. About that. Okay? So it has 100 gram mass. What does that mean? Its weight is on the surface of the earth. On the surface of the earth, its weight is about 1 Newton. Right? Okay, then what do? I hook spring balance, which measures force. I hook spring balance on it. I make a small hook here, right? And then I hook it, and then I let it go. So that means I hold on the spring balance, and then check the number. The spring balance will read 1 Newton. Right? Why is that? So we'll talk about that in future, in the next episode. Why is that 1 Newton? That is measuring its the weight of the object. That is the force the earth is pulling down. So that's exactly the same amount of force the spring balance is measuring, 1 Newton. But now, let's think about this. Right? When I was holding spring balance, I don't have a spring balance in my home. I cannot access my lab at this point. University is closed. So I cannot show that experiment, but you can try if you when the school resumes. Okay, so what do is I let the spring balance fall. I let the ball in the spring balance, which is hooked to this ball, I let them go. What will happen? What will be the reading in the spring balance? Please think about this. This is a very important question. What will be the reading of the spring balance if I let the combination of, that means the spring balance hooked with the ball, I let them go? How much will be the reading in the spring balance? What Newton? Okay, so I'll do a qualitative demonstration with you guys here. So I have a tube. This tube is the tube for these balls when we purchased, right, like this. Okay, so there are 3 balls. Okay, I would like to ask you a question. The question is this. So I hold on the tube, and like this, and move my hand, move my lower hand, my left hand out of the path. So please watch. What happens? The balls fell. The balls fell. Okay? Why? Because there is gravity. And we know that. That is not very interesting. That might not be very interesting for you. But please watch a slightly different demonstration, which I am going to do now. So let me see. Okay, so probably you can see up to this point. This happens very fast. So you may not notice. But you can do this kind of experiment in home with different things. In that case, you need to be very careful. So I'm not introducing that. I'm not telling you that experiment here. You might, when you do that kind of experiment, you might hurt. So I don't want to tell you now. But you can do this simple experiment. You need to have a tube, any kind of tube. You don't need plastic. You can have any kind of tube, and objects which fit into this, and they can move freely. So please watch. Before that, I would like to ask you to do prediction. What does physics do? Physics does prediction. Physicists do prediction. Okay? My question to you for prediction is this. I am not letting my hand out of the way and holding this tube by my right hand, but what I am doing is I am letting the tube itself to fall along with the ball. So what I mean by that is what I am not holding the tube with my right hand. I let the whole system fall. You following me? I let the whole system fall. My question to you to predict is, will these tennis balls come out of the tube during the free fall when they are falling? Okay, let me repeat the question. The question is this. The question is this. When I let the system, the whole thing, the balls as well as the tube fall, okay, this is very important question. Not only for junior level students, even for college students. Okay, it is very important question. Please think about this seriously. Okay? Actually, this is a kind of thought of Einstein. Okay? So what I am saying is, I am letting this tube fall. Okay? Please watch. Please watch whether these balls come out of the tube. It happens very fast because I am doing experiment in the Earth's gravitational field, and the acceleration is 10 meters per second square. So it happens very fast to watch. But try your best. So let it go. So 1, 2, 3, go. Did you notice? Did you notice? Did you notice? What did you notice? Did the balls came out of the tube during the fall? Please try this kind of experiment. But again, please be very careful while doing the experiment. Don't hurt yourself. Okay? Let me repeat this experiment one more time. So what I am doing, I am letting the tube and ball go at the same instant. Okay? Okay? So please, what do you watch is please focus on the balls, whether the balls come out of the tube or not. Okay? Please watch. 1, 2, 3, go. What did you see? Okay? What did you see? Did you see the balls came out of the tube? Okay? So please write comment whatever you saw there, and why do you think that happened? So, okay? So this is the concept related to what we call free fall. Okay? And not only that, it is connected with a bigger concept of weightlessness. 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 So, what is weightlessness? Of course, weight is weight. Less means nothing. There is no weight. So, losing the weight. It is not the losing of weight because of some therapy. Okay? This is the concept of weightlessness. Students, please write this word. Parents, please help your students write this word. Weightlessness. Weightlessness. That is a single word. Weightlessness. Okay? So we'll talk about this concept in depth in episode 5 next Saturday. Okay? Weightlessness. What is weightlessness? When will an object lose its weight? Okay? Do we need to be in space to lose the weight or to observe the weightlessness? Do we need to be in gravity-free space to observe weightlessness? Okay? So there are a series of questions. Okay? So with that, let me summarize. With that, let me summarize. What did we do today? I introduced a new concept. Okay? What was the new concept? Momentum. Right? A new concept in physics. Momentum, which is nothing but the product of mass and velocity. Momentum is a vector quantity. It is extremely important. Please try to understand the difference between vectors and scalars. In future classes, I will definitely talk about that. Okay? So, momentum, I introduced a new concept and I did some demonstrations on Newton's first law of motion. And then I also did a small demonstration on free fall, which we can use to explain the idea of weightlessness. I would like to thank all of you from the bottom of my heart. Okay? So you are doing good job. Okay? Thank you so much. So please ask questions to your parents, to your teachers. Okay? If you do not get an answer, please don't be frustrated. We will be learning lifelong. We will start learning when we were born, and that learning will stop when we die. Okay? So, please don't worry. Please don't get frustrated. It is the process. We need to develop it as a culture of learning science. It will not happen overnight. Okay? It takes time. Okay? So if any of you are new, I am completing my teaching 28th year in formal setting. Make sense? Takes long time. Right? It takes time. And I am learning every day. I am learning new and new things. So learning and teaching never stops. Okay? So if you like this session, right? If you have any questions, please comment at the bottom. If you have difficulty in understanding me, so please suggest how can I do better. I found a couple of comments. The video quality was not high. See, I am doing things with minimal technology, whatever I have around. So I'm not trying to do any professional high quality video. I'm trying to communicate physics, concepts in physics to the young children who would like to learn more. Okay, that's my goal. So I would like to thank you finally and say, please stay safe. Please stay safe. Please stay tuned. Okay, I love you. I care you. Okay, so thank you so much. Okay, so I'm stopping my video now. Have a nice time. If you are in Nepal, good night. In people all over the world, Please stay safe and have a good time. Thank you. Bye.